Alright, so let's have a look at this question here. We have a cubic function. But before we get into that, I would like to ask if you are new to the videos or if you are new to the channel, I would like you to please subscribe so that you won't miss when a video gets uploaded. And if you're coming back, thank you so much for coming back. Let's see how we're going to be learning from this video. So by the end of this video, you should be able to actually understand what is it that you're supposed to do when you're given a cubic function that only has turning points and you're looking for those unknowns there. All right, so without wasting any more time, let's do the instruction there and then go straight into the answers. So h of x here is equals to x cubed minus 3 over 2x squared plus cx plus d is sketched below. A and b are the turning points of h at x is equals to minus 2 and x is equals to 3 respectively. C is the y-intercept of h, and then d is the point which is 4:0. So firstly, let me first make sure that I write this point here so that I don't forget it when I actually have the time to use it, or when it's time for me to finally use it. All right, so now what's the first thing here that is happening? So the first thing here is whenever you're given these type of questions and then you want to find an unknown, you always need to take note of what is it that you're given, right? So here in this case we are given turning points, so which means the way we're going to be approaching this is going to be differently, right? So which means if I want to find C and D, I'm going to be approaching it that differently, and that's what I'm going to be teaching you right now in this video. So let's go ahead and look into 10.1. And as you can see in 10.1, it says you need to show that C is equals to minus 18 and D is equal to 32. All right. Now, because of we're given turning points, the easy way to always find those unknowns, it is to first take the equation that we're given. So I'm going to write it here. X to the power 3 minus 3 over 2 x squared plus cx plus d. Now, because of here we're given the x coordinates of the turning points, we know that when we have a general cubic function, the only way we can basically get a turning point is if we take the derivative of that and make it equal to 0. Now remember, when you have this equation, let's say you have everything here, you don't have unknowns, and then you calculate turning points, you always do this, and this gives you the x coordinate, right? And then now in this case here, everything is reversed. We are given the x coordinate, but we just want to find what was the unknown that basically ended up having these x coordinates, right? So that is why we need to start with this, because the key word there, the key word that we're given there was the turning point, right? Okay, so from here we're gonna then differentiate this. So when we're differentiating this here, we're gonna have 3x squared, and then here we're going to have minus 3x, and then plus c. This will then be equals to 0, right? And then now from here we know that having this will then it will to basically end up having one of these x values. So what we then do from here is we need to then sub one of those values. So in this case, I'm just going to sub x is equals to minus 2. So when I sub x is equals to minus 2, you will notice that here I'll have 3 into minus 2 squared minus 3 into minus 2 plus c equals to 0. And then I'll just press this on my calculator. So when I do that, let's see, minus 2 squared minus 3 minus 2, and then it gives us 18, right? So now here I have 18 plus c equals to 0, and then as you can see here, our value for c is equal to minus 18, which is what we have there. Then now to get d, notice that when we're doing the turning point here, we couldn't basically get have d here because d is a constant, so it became 0. So which means now to get d, what we're going to do is we're going to go back into our original formula, but then when we get into that original formula, we need to make sure that we update the information that we have. In this case, we have c as minus 18. So now I'm going to write this as minus 18x plus d, right? Now, whenever on a cubic function you want to find an unknown straight from the original equation, it is always easy to do that using what? Using a coordinate, right? Now, if you remember earlier, we were given that a coordinate of d, it was what? It was 4:0, right? So always remember this, just before I continue. Whenever you're using a turning point, or we started with a turning point, just know that this will just require you to have an x coordinate, right? And then when you're working with an original formula or original equation, it will need you to have the coordinate, right? Or any coordinate that is d, right? Now in this case here, we're going to use the coordinate for d, which is 4:0. Now by using this, it will basically help us to find the value for d, right? So let's go ahead and do that. So here I know the y value is 0, so this is 4 cubed minus 3/2, 4 squared minus 18 into 4 plus d. Again, I'm going to press everything there. So I'm going to say 4 cubed, where is cubed, there is cubed, minus 3/2 into 4 squared. Then I'll say minus 18 into 4, and then I'll just press this. You see here it gives me minus 32, so it means now here I'll then have 0 is equals to minus 32 plus d. Then I'll take the 32 across, so it means now here I have 32 being d, therefore d is going to be equals to 32. And that is how we basically find the value of c and the value of d. Alright, so now let's go ahead and move into the second one. Now when you go into the second part, just know that already now you have the equation as y equals to x cubed minus 3/2 x squared. Remember c was 18, and then d it is 32, right? So now even if anything that's happening after, even if you didn't get these values, just I want you to understand this, even if you didn't get these values or you couldn't answer 10.1, because of they've told you these values, you can actually use them here to answer other questions. So don't ever give up because you couldn't get this one, then you feel like these answers you get them incorrect, because you won't, because you're going to be using these values to answer the following questions, right? Okay, so now the second question here, now it says we need to calculate the coordinates of A. Now coordinates of A, you can see there, that is the turning point there. So to do that, we know that it has x is equals to minus 2. So now we're going to use the x value, which is minus 2, and then we're substituting it there. So when we're substituting it straight from the original equation, if you remember, I said original equation, that's where you work your coordinates, and that's what we did also when we were finding that value for d. So the same thing here, we want to find the y value of the turning point. We need to just substitute it there and then press this into our calculator. Now I didn't want to bore you, I just paused the video, press the calculator. As you can see here, we get the y value of 54. So this then means here the y value here is 54, and therefore the coordinate here of A is going to be minus 2 is to 54. Alright, let's go ahead and look into that question. So the third question now here, it says determine the x value of the point of inflection. All right, so the point of inflection, I like to call it POI, is basically, you basically get it when you take a second derivative, right, and then make it equal to 0. So we know that already we have our equation. Let me write it here as x cubed minus 3/2 x squared minus 18x plus 32, right? So now what we need to do is we need to first find the first derivative of this, right? Now the first derivative is going to be 3x squared minus 3x minus 18. Notice I didn't equate this with 0 because the one that I need to equate with 0, it is the second derivative. So it means now here I have my first derivative. I need to then differentiate this derivative, so which means it's gonna give me a second derivative. So when I do that, this basically gives me 6x minus 3. Now this is the one that I want, so which means now I know that my second derivative needs to be 0 at the point of inflection. So from here I'm going to say 6x minus 3 equals to 0. 6x equals to 3 divided by 6 divided by 6, and then x is going to be 1/2. So that is the x value of the point of inflection. Alright, so now let's move on into 10.4. 10.4 says write down the interval for which h is concave up. Alright, so now when you speak of a concavity and increasing and decreasing, it's very important to understand what those means, right? So Basically, the word increase, it means going up. In this case, you can see that the graph is going up there. Then decrease, it means where is it going down? You can see it's going down there, right? And then again, it is going up that way, right? So all of these, we call them increase and decrease. So if it is increasing, it means your derivative will be greater than 0, or it will be positive. Then if it is decreasing, then your derivative, notice that we're talking about the first derivative here, to be less than 0. Again, if it is increasing, and then the derivative, it will be greater than 0. Now, when you talk about the concavity speaks to the second derivative. So the concavity states that if the graph, it is concave down, right, then the second derivative, so I'm going to write it there, needs to be negative, right? And then if it is concave up, then the second derivative needs to be greater than 0. Notice that here I used f, but it's still the same. It still works even if it's h there, right? I was just writing it in general, but then since we're working with h here, we're going to be focusing on the second derivative greater than 0. Now, where is this second derivative at, right? If you remember the second derivative, we said greater than 0. That's when we were talking about the point of inflection when we had the second derivative, right? So this means now here at this point here, we can say this is where our point of inflection is at in this case. And then we know that the x value there was x equals to half. So it means at the right of this x is equals to half, that's where it is concave up. And then at the left of that, that's where it is concave down, right? Now, to answer this question, the question here, I know I took so long because I wanted to give like all the information, but then the question here was basically asking to write an interval for which h is concave up. Now, in this case, we know that h of x, right, or h is concave up when the x value, right, is at the right of 1/2, right? So let me just write it like that, right? So the easy way to write it is actually to write it like that. So that's the answer for 10.4. So let's move on into 10.5. 10.5 states that if g of x is equals to h of minus x, write down the coordinates of the turning point that is the image of A. All right. So now here, what is happening? Here, they're saying that if a new function, which is g, is the same as h of minus x, then now we need to find the turning point of that g, which is an image of A, right? Now, the easy way to understand this is to look at what we have. We know that here we're dealing with h. So let's look at this h here, this new h here. What is happening here? This new h here, you can see that it has a negative x. Normally, it had an original x, but then now it had a negative x. So what does that mean? So the minute the graph has a negative x, it means that it is reflected, right? Where about the y-axis, right? If this was a negative, if it was, let me just put it there, the star. If this was g of x equals to negative h of x, then this would have meant that it has been reflected. So I'm just going to write about the x-axis. So I'm throwing all this information because I want you to just have an understanding of this. But we're going back into this one. So if the graph is reflected about the y-axis, it means now this point here, but we had, I'm trying to find a brighter color. Let's use this one. So this point that we had here, it has been reflected now. It's on the other side, right? So now the question here is, what is going to be the coordinates of that? So because of we just changing the x value, right? This image of A, right, will have the same y value, which was 54, but then now this negative 2 is going to have a negative, because remember negative, this is negative 2, right, which will then be 2 is to 54. So that's what it means to reflect it about the y-axis. It means here we're changing the x values, right? So if this x value was negative, the side is going to be positive. Same is true with this one. You see this one was positive, then when it flips up about the y-axis, it's going to become negative that side. All right. Okay, so now let's move on to 10.6. 10.6 here says that determine, actually let me just open another space because I did some lot of drawing there, so I want to explain this one without actually clearing that one out. Okay, so here they're saying that determine the values of k for which, sorry, yes, determine the values of k for which h of x is equal to k has two unequal negative real roots and one positive real roots. Okay, so now what is happening here? So here we want to find the values of k, right, which will basically give us two unequal negative real roots and one positive real roots. Okay, so firstly I want to speak about k. What is k? So let me write this question. What is k? So k here is a horizontal line. All right, is a horizontal line. So what do I mean by that? It means it's a line like so, right? Any line that is horizontal, right? Now how this line works is that it cuts on the y-axis, right? Most cases, right? It cuts here. The most significance of this is it always intersects. Let me put it this way: it always intersects the graph, right? So here we are looking for the x values, right? We are looking for the values of k, right, of this constant, where when it cuts the graph of h, right, it will cut at the areas where it has two negative roots and one positive root, right? So that's basically what we're trying to do here, right? We're trying to look for an area or a section or an interval of this horizontal line where when it intersects the graph of h, it will be basically cut it into three areas. Two of them will have negative x values and one of them will have a positive x value. Now to answer this straight, what we're going to do is we'll first need to look at critical values, right? So the critical values here, it is the turning point. If you remember the turning point here, it was -2 is to 54. So the critical point there, let me just put it this way, -2 is to 54. So the critical point there, it is that 54, because remember k is a horizontal line, so which means it is a y value, right? It means the y value. So I'm focusing mainly on the y values. And then here we had our y-intercept. That's also another critical value. And this y-intercept, remember, it is d, which is 32, right? And then now also other part, it is this one, but we don't need this one necessarily. We just want to focus into this section, right? Now if you notice in this section, if I draw the line here or the value of k here, you can see that actually this value of k, it does intersect here, and there, right? And the x value here is negative and also negative here, but then here is positive, which means now within this interval, if our horizontal line is between there, then this horizontal line, when it cuts the graph of h of x, it will cut it into 3 points. Two of those points will have two unequal negative real roots, and the third one is going to be a positive real root, as you can see here, two negative and one positive. So this then means now the answer here that we need to write for k, we need to say k is in between, right? In between these values 32 and 54. 32 and 54. Now please take note of this, right? I'm not saying that k also includes 32 and also includes 54. Why can't I say that? Because if I include 54, notice what's going to happen. You see that it's going to touch once there, right? And then it will touch once there. So it means here, these roots here are going to be equal. They're going to be negative, but they will be equal. But we want a place where they will be unequal. So it's going to be two roots there, both equal, and then one positive root there, right? And then with this case here, if we touch at 32, it will be negative here, but then there it will be x equals to 0 because it's a y-intercept. Then that one, it will be positive. Hence, we can't have that one. But that is how we basically get into this answer. And I know that I've said so many informations there. I hope you basically find a way to take all of that information down and take all the notes down. And if there was anything that you liked or you want to get to know, please make sure that you leave that in the comment. And also, please don't forget to share this with your friends. Maybe this might be beneficial for them. They will actually understand how it works or what's the approach when you're given a cubic function scenario that has x values of the turning points. And until next time, stay blessed for the best, and I hope to see you on the next video. Cheers.